Okay, so now we are going to, this is the second part of lab sheet 5B. We're going to do running cylinder pressure testing now, and then we're going to sync it. So the first one will be just running. We've changed the time, the time base is the same. Actually, we've changed the time base to 2 seconds per division. It was at 5, and I've changed the PSI now to a lower setting, minus 100 to 70 PSI. Running compression will always be lower than static compression. Running compression we used to do with a gauge, and we'd be looking for about 50% of static compression at idle. Okay, so we're going to be in that area now when we do this. So we're going to look at this at idle, and then we're going to add a reference cursor to it. So all I've done to change things is put the relay for the fuel pump back in. I've still got my fuel injector unplugged. We don't want to spray fuel into the cylinder.
It's up.
Okay, so our engine is running. I've got this stop. We'll just unfreeze it. And there we go. So we can see our pattern coming across the screen. And I'm now going to stop it. And then I'm going to zoom in. Alright, so we can see our pattern here. I'll zoom in again. So it looks quite a bit different than it did cranking. Alright, so what are we looking at here? Let me just shut this engine off and we'll talk about this pattern here. Who else is here? Okay, so as we can see, we still have our pressure peaks, but now we have what we call an exhaust pocket. So when this compression stroke finishes, we have our power stroke here, and at the bottom of our power stroke, because this cylinder is not firing, right, the spark plug is out of this, it's simply we're looking at the sealing ability of this cylinder. When this piston reaches bottom dead center, it's built up vacuum in the cylinder because the valves are both closed, of course, on our power stroke. So that's what we see here. We see what's called our vacuum pocket at the bottom here. And then we have our exhaust stroke. Okay, so our exhaust valve is opening right down here, and we're building some pressure in the cylinder as we're pushing that air through the open exhaust valve. Of course, the higher this peak is, it's going to indicate possibly a restriction in the exhaust. If I have a high peak on this pattern, that air is having a hard time getting out of the cylinder. Okay, and then we can see our intake stroke and our compression stroke happening over here as well. So we're going to do the same thing with this one. I am going to copy as image, and then we're going to go to our stroke overlay like we did before, our pressure waveform, and we're going to get rid of that one, and we'll open up a new one here, and we're going to paste our new image onto this one. Alright, so we will get this, fill up our screen with it, and now I'm going to put my overlays on this one, and we will line this one up with our peaks as well. So we are 720 degrees crankshaft rotation. You can see on the bottom scale here. So each one of these are 180 degrees apart. Okay, so this would be bottom dead center, top dead center of my exhaust stroke, bottom dead center of my intake stroke, and then we go into our compression stroke once again. So I can put on my overlay here as well. Alright, so line up where our intake or exhaust stroke begins. So there's where my exhaust valve opens, and my exhaust valve closes It's kind of hard to tell with this one, but we are going to be in this area here. My intake, though, is going to open right here where that pressure peak is. And we're going to close there. We can see the pressure change. And then that's pretty much where we're starting to develop pressure on our compression stroke. So we can see where our exhaust and our intake valves, the range that they're operating in. Alright, so now I'm going to leave here and we'll go back to our live scope image, and now we're going to sync this with number 1 cylinder. So I'm going to turn on my number 1 cylinder here. We can see our red trace as well, and now I'm going to start it again. Okay, so we have a capture there. And we will freeze this, go back a screen. Alright, so here is where we are. We're going to zoom in on this. Alright, so we can see our ignition pulses for that cylinder. We'll just zoom in on, we'll grab these two here. Okay, so we can see when ignition takes place versus the peak of compression. We're running now, so obviously we should be more advanced than we were cranking, which we can see that we are here. Okay, so what I'm going to do is drag the cursors over once again. Of course, my time should not have changed for my total 720. We're at 135.7 milliseconds for 720 degrees of crankshaft rotation. So now we're going to move this to the peak of our ignition event, and we're going to move this other one to the peak of our tower here. Alright, so between ignition and the peak of compression we have 4.377 milliseconds. Alright, so you're going to need those numbers. You're going to need the numbers from what we just looked at for 720 degrees. And you're going to calculate timing, ignition timing, based on degrees of crankshaft rotation. So how many degrees of crankshaft rotation is my timing advanced at idle on this engine? Okay, and one more thing we're going to do, now that we have these up here, it's not on your sheet, but we're going to do it anyway, is we are going to do this snap throttle. And you're going to see wide open throttle, how this is going to affect our pattern here. So I'm going to move these out of the way. I'm going to turn this back to live. Alright, and I'm going to change my pressure because my pressure is going to increase, obviously. So we're going to go up to our next scale. And my voltage, I'm going to go up to the 200 volt scale as well. Okay, and we will make this live. We're going to start it, and then we're going to snap the throttle a couple of times. Take a look. Okay, so there we are. We'll snap the throttle. I'm going to shut her off. Alright, so we're going to come over here, stop it running. We're going to back up to our screen so we can see where we snap the throttle here. So I am going to zoom in on that. Okay, so we're going to zoom in once again. We'll pick these two. That looks pretty good. Alright, so we can see that we are much more advanced than we were just a minute ago. Now, it's not a great image. It's clipped it off a little bit. When we get up to the higher PSI, it's not quite as good resolution, but that's fine. We can see, actually, let me just see if I can find one that's got more of a peak on it. There we go. These ones are a little bit better. So we're going to move this across the screen here. All right, that's what I want right there. So we're going to zoom in on this one. Okay, so we'll reduce this guy, get him out of the way. Okay, so we can see here snap throttle. All right, you can see how it's affected the exhaust opening. It's much, much more rapid now, and we're not seeing it with the pressure transducer. Okay, but what I'm going to do is bring my cursor out again, and we're going to go, and how many degrees of crankshaft rotation do we have now? So now we're at 4.037 milliseconds. How many degrees of crankshaft rotation is that, right? Our 720 degrees should not have changed. We're at 48 milliseconds for 720 degrees. And for our ignition event, we are at 3.828 milliseconds. Okay, so you can see the advance in timing at higher RPM in degrees of crankshaft rotation. If you want to calculate this one as well, that would be awesome. You don't have to, but it would be good. All right, so that's it for Worksheet 5B. Get it submitted today with Worksheet 5A, and I will mark them and enter your marks. That's it.